Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm excited to be talking today with Insiya Jafferjee, co-founder and CEO of Shellworks. We'll be talking about what Insiya's company is doing to make plastic waste a thing of the past by developing and offering a sustainable alternative. I'm really glad to be focused on this because while plastic is amazing in so many ways and we rely on it in almost every facet of life, it's also all kinds of bad. Less than 10% of plastic used globally gets recycled, and the rest ends up polluting the environment one way or another. And then plastics production is responsible for 3% of global greenhouse gas emissions. So, of course, if we could reduce our dependence on plastics, the planet would thank us. To introduce Insiya quickly, her background is a blend of design, manufacturing, engineering, and entrepreneurship. And she plays at a really high level in all of them. She's worked in engineering and manufacturing at Apple. She has a master's degree from the Royal College of Art and Imperial College of London. She studied product design at Stanford. And luckily for all of us, she's channeling her experience and energy towards realizing a world without plastic waste through this amazing company we'll hear about today. So welcome, Insiya. It's really a pleasure to have you on the show. Thanks for joining us.
Thank you. Thank you for having me.
Before we get into Shellworks, I'd love to learn more about your background. How did you get here, and what have been some of the major inspirations along the way?
Yeah, of course. So I'm actually Sri Lankan originally. So I grew up there, and then I went out to study in the US at Stanford. So very lucky to end up at the farm. In retrospect now, I feel like it was a bit of a resort that I was studying at. But I think for me, I have always loved working with my hands, and Stanford was an amazing place to experience that or push that further because they have a beautiful machine shop. So I would spend from the first year at freshman, I spent a lot of my time there just exploring about how you could make things. And I think that's what sparked my interest, as well as, Stanford has some of the most cutting edge research centers. So I was really intrigued by research and science, although I didn't really have the background in it, and how to combine that with making and bringing that to life. It kind of continued further because I was like, okay, I want to figure out how to make things, but make things at scale. And that's when I went to Apple, and yeah, it's amazing. They make the most, to me at least, in my opinion, the most beautiful products, but also manufactured immaculately. And there I got to learn from, people who are just amazing at electronics. They're amazing at, building things with their hands, some of the best designers. And so it was a space where I could learn not only how to make things for myself, but how to make them at the quality and design and appreciation, but also at a massive scale. But I think I also got to the point where I was like, okay, there's only so many watches I'm going to make in this world. And maybe I need to figure out what's next for me. And that's what's brought me to London, and where I met my co-founder, who happened to just love natural materials. So he was doing architecture, but was known in his department as the guy who grew fungus in the background because he was exploring at the time mycelium before mycelium was really that cool. We just really enjoyed working together, and we started exploring what we could do with natural materials and how we could make with them, and how I could bring maybe more of my engineering and research background. And that's how Shellworks started. It was honestly just our love for experimenting, but we wanted to do it with an impact. And honestly, there's no bigger impact than plastics.
In your opinion, why is addressing the plastics problem such a big deal?
You grow up seeing plastic everywhere. And I think the thing is, plastics itself is not a problem, because plastics is an amazing material, to be honest. And I'm an always all of plastics. It's just that they're used not always in the best application. So a lot of what we think about is how can you use something, design something to last only as long as it needs to. And I think what we see with the plastics problem is a material that's been used, but perhaps for too many wrong applications. And it's that misuse that's what's causing this issue. And how do we bring perhaps maybe more materials into that mix to start reducing the impact of that, and actually maybe celebrating plastic for what it's really good at, which is lasting a really long time.
Before we get into what you're doing at Shellworks, I just have to ask, you mentioned Sri Lanka, and growing up in Sri Lanka, I know it's a place that feels the effects and the potential risks of climate change more than a lot of other places in the world. Has that influenced this path at all? Is that something you think about?
I'd say it's always a combination. I think we call ourselves critical optimists because I never like to talk too much about the problem because I think we all know what the problem is. I mean, growing up in Sri Lanka, yes, I grew up going to swims every weekend. And at some point in my adult life, the swims turned out to be swimming with plastic water bottles. It's never something that you want to do. But at the same time, a lot of how I think about the problem is that there has to be a better way. And it's more about creating that solution that could just be just the best packaging in the world. And it doesn't have to be sustainable. It just has to be best because now we're taking into a criteria that maybe we didn't know to take into consideration before.
Your co-founder and you started looking into alternative materials. Can you talk about what it is specifically that Shellworks is doing to address the problem?
Yeah, of course. So when we first started looking at alternative materials, we actually started at seafood waste. And that's perhaps where the name comes from. So Shellworks was originally looking at waste seafood, and there's this biopolymer called chitin in shells that you can utilize, which acts just like a biopolymer. And so we started exploring creating films, cups. We had to create the manufacturing processes in addition to the material itself because it was really hard to scale. And then somewhere along the way, one of our goals was every 3 months, we have to try and sell something. So we would do the best we could as quickly as we could. And then the third time we tried to sell this material, we realized, hey, we're not doing something correct because we kept getting the feedback like, this is an amazing idea. It's super cool, but we can't use it for XYZ reason. And when we dug into that, it was like, hey, sustainability has to be looked at from many different angles. And if you're using a byproduct, even though it is a byproduct, if we get big enough and we scale that solution, then it no longer becomes a byproduct. And at that point, what do we do? Or it's not vegan and our entire ethos has to hit all of these different criteria. So we started looking at more and more solutions, and we're much more plugged into the ecosystem. And we probably explored everything from mycelium to bacterial cellulose to chitosan. And then we came across this technology, which is based on bacteria. So there are bacteria that exist in soil and marine environments. And naturally, they have an ability to grow a granule that if you extract from their cell behaves like a thermoplastic. But what's beautiful about it is that if you throw that thermoplastic away, the same bacteria in soil and marine environments see it as their food and break it down. So in a way, we're just using nature's most powerful tool to help create our solutions that are more in sync or symbiosis with nature as well.
I just have to ask, you had a goal of selling something every 3 months?
Yes.
And do you literally finding a customer and selling a product? Tell me more about that.
Well, I think maybe it was because we were influenced by software startups as well a little bit, right? Like software startups, they can just reiterate and prototype and test it quickly versus with hardware company, it's a little bit more nuanced sometimes, but we wanted to keep that element. So it didn't even matter. We had, at the beginning days, we were testing things like a film, and we were like, hey, we have no idea how to make films for bags, but there is this exhibition that wants to hang some films from their ceiling. And we're like, if we try, they're willing to buy it, fine, and we'll just try and learn about the manufacturing process. So we sold these film sheets that are hanging in Paris on exhibitions just so that we could learn. And then it was the same with the cups. We were like, hey, we have these cups, but we don't know. I mean, no one's going to pay this much for a cup, first of all. And we were like, but hey, it's a rigid item and we could make a candle out of it. And so we sold candles to learn about the cup manufacturing process. And I think we've done this time and time again. We started working with a perfume company, and honestly, we tried to do everything from their secondary packaging to their trays. And then eventually we ended up doing the bottle caps. So yeah, I think that ethos and that mentality is very much there. And the team is just find a way to get it out the door. And if you set yourself that constraints, you have to scale back. The complexity has to become less. And you do find ways. But yeah, now it's looking more like 6 months, to be honest.
Still pretty good in a hardware world. I love that. I'm going to remember that because I think you're right. It's much more the mentality in software. And I think hardware, it's easy to kind of use almost the excuse of hardware to kind of not get that real world feedback and not force yourself to get the commercial validation. So I love that you really pushed to do that. That's awesome. Okay, so as I've learned about plastics, I've kind of understood there's sort of almost two ways in which to think about its impact on the environment. One is the production of plastic, and traditional plastics are used fossil fuels to be produced. And then there's sort of the end of life. And as I understand it, you can have, because bioplastics are all over, right? You can have bioplastics which means they're created using renewable, often like plant-derived materials. And then you can have biodegradable plastics, which sometimes are also bioplastics, but could also be fossil fuel-based plastics that's about how they degrade in the real world.
Maybe I'll add a third category.
Okay,
so there's
please.
also a category called compostable plastics. The nuance with biodegradable ones is that they don't actually have to degrade in a natural environment. They just have to biodegrade anywhere. So it could be, and that I think is where some of the nuance around plastics is, or where maybe some faith has been lost in newer materials, is that in the past, there were biodegradable plastics, but they don't degrade in a natural environment. So it misled the consumer into believing that biodegradable plastics were going to solve the end of life issue when they didn't. Now they've introduced a new term called compostable, which means that it has to degrade in a compost environment, which is much more representative to a traditional soil or marine environment. Yeah.
Makes sense. And then even in a compostable environment, is there a difference between sort of commercial composting and home composting?
So home compost is the gold standard. If your material can home compost, it means that it's truly quite natural. And then on top of that, there are new certifications like marine degradable as well. But that's another huge level of complexity because a marine environment is so complex and it depends on what layer of the ocean bed you end up on. So maybe not something to dive in right now, but there are many different layers of how you can term your material. But generally, home compostable gives you the sense that the materials being used have to be natural because they're degrading in a very basic home environment.
Okay. So your material is both derived from a renewable resource and compostable.
Home compostable, yeah.
Home compostable. Awesome.
Yeah. No, it's a tricky one, terms in this space, because I think greenwashing it's probably one of the biggest challenges for anyone developing a new material, because it's quite hard to communicate to a consumer what specifically you're doing because there have been so many terms introduced. And then, it's a bit of a challenge at the moment, which is why now we've started just creating visual or physical assets so people can kind of touch and feel and truly understand what's going on.
Mm-hmm. Mm-hmm. Maybe that's a good segue into kind of the business model and how that has gone. I mean, speaking of kind of selling to customers, what exactly are you selling and who are you selling it to?
Yeah, so we decided to start in the beauty industry for a couple of reasons. I'd say the first is it's probably one of the ones that's overlooked. There are a lot of alternative materials that are focusing on the food industry, but beauty contributes to something like, I want to say 180 million units of packaging a year. So it's one of the larger offenders. It's probably in the top 3 offenders of plastic pollution. But not many solutions exist because you need to be quite resistant to formulas. And it's also not something that people traditionally think of as a problem because it's not as single use, but in a way it is single use because once you use your cream in 6 to 12 months, sometimes even shorter, where does that product kind of end up? The second reason we also decided to work here is because our material is quite good. So it is resistant to all these different formulas. And so we kind of have the ability to start telling that story of like, this is just quite good packaging for your product. It doesn't have to be a compromise. And it's a big one of our principles is how do we create a product without compromise? Because we don't feel like a consumer should have to compromise for sustainability. Yeah, and it's crazy. The beauty industry, the more we get to know it, is vast, and you sometimes don't think about it, but a palm pad or a lipstick, for example, is actually 5 different types of material. So it can never be recycled. And it's so tiny that it actually falls through the grates. So it seems like a good place for us to start making an impact and learning a lot. But then our goal is to kind of grow into the personal care and the food space. We hope to enter the personal care and food space after because they operate at much larger volumes. So once we've scaled up, we can start to offer the solutions. But otherwise, we kind of tactically made the choice that we don't want to do pilots because pilots sometimes don't enter the life of the customer. And I think going back to that fact, if we love to sell within 3 months, it isn't in our DNA to kind of do more like in-house testing. We want the real world feedback.
Mm-hmm. And how do your customers look at this? Are they, because I imagine they have all the same, they're subject to all the same greenwashing that you just mentioned, and there's all these other bioplastics out there and biodegradable plastics and stuff. Is it a hurdle to educate them on why what you're doing is different and better? And then do they have to in turn educate their customers? What does that process look like and how are they convinced in the end?
And to be honest, not really. It's also partly, it's another reason we play in this space is our customers are really clued in. They have someone who's probably the head of their sustainability, who's looked at every type of plastic, who understands the nuances of every different end of life, and then they come up with their strategy. So when we say home compostable versus biodegradable versus recyclable versus monomaterial, they know exactly what we mean. And it's also because the beauty industry came under a lot of scrutiny, so they changed their entire supply chain and their ingredients, right? So you'll hear a lot about clean beauty and how natural ingredients are being used. And the last piece of the puzzle is their packaging.
Okay. They're pretty savvy to this. And are they taking, what about from a cost standpoint, are they willing to pay more for this than traditional plastics?
Yes, but also in most instances, we don't ask them to pay more than what they're paying already. So it's a space where they are used to using like a glass container or an aluminum container because they want to be more sustainable. And then we're not just competing with really cheap plastic. And in most instances, if they use plastic, they'll try and use PCR, which in itself also has a premium cost associated with it. So when we stack up against the options that they're using today, we're not necessarily asking them to pay more.
Oh, interesting. So you're actually a preferred alternative to something like a metal or a glass container.
Well, because of the weight, right? So glass is typically preferred, but it's quite heavy. So they're thinking about the emissions related to that. And then with metals, they're not always compatible with all the different ingredients. So, and they can't make every form factor, like a pump, for example.
Oh, interesting. And what about these things like lipsticks that require multiple, you said 5 different materials? Is that something you're tackling as well? Or are you focused on the kind of single material pots of cream and that type of thing?
No, we've gone for the big problems in the industry. So the things like the lipsticks or the pumps that have 7 different types of material, that's what we want to tackle. So, one of the beautiful things about the bacteria that we use is that based on the different type of bacteria, you can create a completely different material. So we can offer the same end of life, but in something that degrades, that has something different material properties, So something flexible and rigid, but if you throw it away in compost, it will all degrade the same. So it's one of the things that we're quite excited about and exploring now. It's not out in the market, but it's how we're doing a lot of our development.
Okay, cool. I've seen on your website, I don't know if I'm saying it right, Vivomer?
Vivomer.
Vivomer? Okay.
Yeah.
Is your brand name for one of your plastics?
Exactly.
Would these other plastics be all, like different product lines, essentially?
Maybe it'll just be Vivomer Flex.
Nice. Nice.
But yeah.
I love the name, by the way.
Oh, thank you. Yeah, it comes from, naming was actually, oh my goodness, I spent hours and hours. People, naming something is hard. It's very hard work. We finally came to this because we were like, oh, it's kind of like a living material, living polymer. And then we were like, okay, Vivomer. But man, we went through hundreds and hundreds of names and brainstorms after brainstorms and voting after voting. And in the end, we were like, we have to pick one.
Yeah. Well done. And you've told me before that you hold a really high bar in terms of what applications you'll pursue for your product. There are all these other examples of sort of plastic alternatives in use today. Can you tell me a little bit about what that bar is and why that's important to you?
Yeah. I think we believe a lot in the longevity. So there's always a stepwise progress you might need to make. And in the past, again, I think it's not necessarily the wrong product that was made. It was just marketed wrong. It was marketed as biodegradable, which led the consumers to believe XYZ versus if they had just been this is a renewable material, but behaves the same as plastic, we would have had a better chance. But because of this murkiness, now for us at least, we feel like holding ourselves to the highest bar because we believe that's where the longevity comes from. Because consumers have lost so much trust that if you do something that's a compromise, it's quite hard for you to revive your brand. At least that's our opinion, and that's how we operate at the moment. But there are other amazing companies in this space as well who hold themselves to the same standard. And yeah, what's the quote? A rising tide lifts all boats. That's one we use often in this community. And there are great seaweed packaging companies, and their technology is again completely natural. And they've also been looking at which specific application to make. So there's one in London that's called Notpla that does these seaweed-based sachets. There's one in California called Sway that does these bags. And so everyone's kind of found their space that they're operating in. And a lot of it is now, how do we grow? How do we grow so that we can, because plastics is, someone told me this recently, one of our customers, that they were like, oh, we want to replace our baby scoop. But obviously our baby scoop, we sell 500 million a year. One baby scoop for one SKU. And we're like, okay, cool. So we're just making 100,000 right now. For us, that's a huge number, but 500 million. So we're all trying to just get to that scale so we can make the impact we want to make, right? Because plastics is such a huge problem that just one SKU, even if we can make one SKU at 500 million, we'd start to get there, start to put a dent. But yeah, I do think there's a shift to more and more of us, even though we're really happy to test and iterate and get stuff out there, not to compromise on the sustainable values, because consumers have started to really understand the nuances. And that's been really helpful for us. But equally, it holds us accountable to what we're doing and how we hope to grow.
Mm-hmm. Yeah, just thinking about so I guess you could compromise on the material itself. And then also in some of the applications, I could imagine there might be, the material is biodegradable, but it's laminated with something that's not biodegradable, or it's assembled with something that's not biodegradable. So in reality, you can't throw the whole thing in the compost. Is that the kind of compromise you're trying to stay away from?
Yeah, exactly. So when we say monomaterial, we mean that we don't use anything outside of one singular type of material, and we don't use any synthetic dyes or pigments. We don't use adhesives. It's a long list. And it does sometimes, sometimes we're like, oh, we're making our lives really, really hard. But then, I don't know, I do think constraints are really interesting. Because if you have a set of constraints and you have a set of people who are like, yeah, we're just going to do it anyway, you'll figure out a way. And a lot of the time, the team has found different ways to assemble things, or different ways to create a mechanism, or different ways to assemble the product. So design has played a really large role in how we approach problems. And it's also been a key to our success, I guess, because we're just always like, okay, well, we have these constraints and we can't use these things. And we're not afraid of those applications either. When I talk about a pump, in the beauty industry, it's probably the hardest thing to achieve. But we'll just be like, okay, how do we redesign it so that we don't have to use an adhesive or a glass piece or a metal bowl? We'll find a way. Yeah.
Yeah, that's a tough, even a spring. Don't they all have a little spring in that mechanism?
They do. But then you could use and it's the company that's done a monomaterial pump with a plastic spring, right? So then it's, how do we achieve those material properties in our own material so that it's compostable and monomaterial?
Yeah. And then what about on the disposal side? I've been reading about how even organic materials that end up in the landfill, they've excavated landfills, and 50 years later, carrots are still orange. So I imagine there's some amount of education that needs to happen for you to really realize the end of life benefit here. Is that true?
Yeah, end of life is a huge challenge because it requires working across different disparate counties and waste systems that all work in completely different realms. So some of it is looking at applications that can't be recycled, right? So this application could never be recycled, therefore it's always going to end up in landfill. And if this ends up in landfill versus a piece of plastic, if there's more organic material in landfill, the more ability for a landfill to actually degrade properly, more like a compost than a landfill, right? So there's a little bit of that. But then in the background, we're actually working on a grant with the government, the UK government, to test out all these different scenarios. So what is actually the truth behind our material in a landfill? What is actually the truth behind our material if it's littered? Because while we can't solve all of these problems all at once, at least we can be extremely transparent about what is happening and why. And the partners or the customers we're working with are totally on board to help us spread that message to their end consumers as well. So some of the work we did with our first launch partner, Heckles, which is an extremely supportive partner, they've like really shared like how home composting works. And if you have access to home composting, like at week 1 versus week 2 versus week 3, like what should you expect? So yeah, we're if you can't compost, like please bring it back to us. So that's like the other story for these brands. So we're taking steps, basically. It's probably one of the hardest problems, and it's not going to be just us to solve it. It's going to be a multi-pronged approach. It's going to be an improvement in recycling. It's going to be an improvement in organic waste. But we're quite excited at the potential of organic waste because, at least in the UK, people still can compost more than the rate of recycling, for example, or people have more access to food waste than they do of these other systems. So we're definitely pushing in that realm for our products.
And I guess even if it does end up, there's so much plastic in the ocean, for example, and then you read about the crazy microplastics problem where, as I understand it, all these plastics are degrading, but they're not biodegrading. So they're just being broken down into tiny little pieces.
Yeah.
But if Vivomer ends up in the ocean, it'll actually disappear.
Degrade. Yeah.
Like fully degrade. Yeah.
Yeah. I mean, I think we always call ourselves critical optimists because we would really love for everything to end up in its right place. But we're also aware that right now that's not the case. And so we do kind of design our products for that worst case scenario. Although, yeah, we have strong ethos in how we package that information because it's not a license to litter either. Just because this material is natural doesn't mean that you should throw it away with like irresponsibly. We still want people to think about where they're throwing things and be conscious about that. But equally, if they aren't able to, then it won't impact the environment in the same way.
I want to get a little bit more into sort of the technology here and the process. So it's based on this waste product from microbes that exist in nature. Where in this chain does Shellworks get involved? Are you culturing microbes in your facilities? Are you buying this waste product from somebody else?
So it's maybe a correction there. So it depends on who we work with and it depends on the scales. One of our largest partners uses a waste renewable source to feed the microbes. And then the microbes, through fermentation, create this granule that when we extract behaves like the thermoplastic. So that's at scale. We work with a couple of different partners to get this granule, and then we formulate it into pellets that work within injection molding, tooling, and products. In the background, we also do our own research on new strains and new microbes and new materials. So kind of like I mentioned, this set of microbes, they have the ability to create all these different types of materials that open up new applications and new processes. So yeah, we do dabble a lot in every space. It's probably the nature of who we are and how we act. But primarily, a lot of our innovation today has been more on the formula side, like taking something that isn't easily processed or manufacturable and been able to be made into products and figuring out how to work with the materials, but also the tooling, but also these other elements, like how do you pigment something that's natural with something natural, or how do you create a monomaterial solution with something that may be easiest material to work with. So those are kind of the complexities that we solve at the moment. And then we're looking at how we can add to our material set by doing further R&D.
So what does the process look like once you take these granules? What happens from there?
Yeah, so it's a lot of us working with traditional manufacturing plastic processes. So there's a process called twin screw compounding where you can create different formulas and you create the pellets. That's how all traditional plastic pellets are often made. And then right now we do injection molding. So that's how we make our parts. And more recently, we're starting to explore what are the other manufacturing processes out there and how could we also create formulas that work for these other processes.
Mm-hmm. What's one of the biggest technical challenges you've encountered?
Manufacturing this at scale. So creating both the formula and the tooling to work hand in hand in order to create a product to the level and quality and aesthetics that we want, essentially, so that you don't have to compromise. I think aesthetics is a huge one for us. We want to create something that's beautiful because in a way also we don't necessarily want to encourage people to throw things away. So there's a little bit of that as well in our ethos, especially because we're playing in the space like beauty. People could keep those products. They are beautiful. And at the end of the day, like everyone at the company or us as people, like we don't like consuming too much. We live that kind of lifestyle. So we also want to create our solutions to fit within that.
Mm-hmm. And the challenge of cosmetics, is it things like color and texture, or is it about sort of the injection molding process, draft and parting lines and sync and stuff like that? Or where does that come into play?
I'd say all of it. All of it is all the challenges. We only use natural dyes. I mean, natural dyes inherently have a lot of variability. Yeah, all of the challenges you would imagine with injection molding, and then you times 10 it because it's a material it's new. Mm-hmm. It's in plastics at millions of years, not millions of years, thousands of years to get perfected, perhaps hundreds. But yeah, we probably just need a bit more time iterating and testing and iterating.
Mm-hmm. And then the other angle I was thinking about this is, as a mechanical engineer, and a lot of people I work with and know are engineers that design plastics into products all the time.
Yeah.
How should people like that be thinking about Vivomer and other these types of plastics? And is it a drop-in replacement? And will this be a potential material to be used in future products, or is it different from that?
Yeah. The goal is always to make it as easy as possible. And so drop-in is something definitely we think about. But I don't know. I think the way to really think about it is just to start understanding what it means, right? Because it's going to require more people working on it with these new materials in order for it to really proliferate. And whether it's our materials or seaweed-based plastics or mycelium packaging, the more people that are testing and trying them out and figuring out how to make these applications. I mean, everyone's always quite creative in their design process and engineering process. And so they might discover something along the way and that makes it really good for a certain application. So yeah, I think mostly just trying to understand the nuances of the space. And yeah, I know it's quite hard to get your hands on these materials these days because it is very limited, unfortunately. And most of us are still at a bit of a smaller scale than we would like to be. But yeah, just trying to be at the frontier of testing stuff is probably the best way, because yeah, hopefully it'll be a drop-in, but if it's not, it's just like working with another performance material. And I think there's many performance materials that require slight nuances, and it's a little bit more of an art than a science sometimes.
Mm-hmm. Thinking about the future a little bit, what's next for Shellworks? Do you have things on the roadmap that you'd like to talk about, or that you'd like to focus on?
Right now, we're just focused on scaling. And then, yeah, I would say that's our biggest challenge, is trying to get these at a larger scale, and then new product development to tackle some of the bigger issues in the beauty industry. We started with something less complex, like a jar is a less complex product. So now we're leveling up and trying to go for the harder battles.
You've talked about scale a little bit. I mean, it is such a massive, the numbers are just kind of mind-boggling, like your baby spoon example. I guess, how do you wrap your head around that? Do you think there's a world beyond plastic waste? And what do we need to do?
Of course there is. 100%. I think the best piece of advice I got is that you can only look at what the next stage is, right? So we did 5,000 and we did 25,000. Now we're doing 250,000. And then we'll do a couple million, and we'll do 10 million, and we'll do 100 million. That's just how it goes. And sometimes it can be a bit daunting if you're like, oh my goodness, how do I get to 500 million? But it's not as daunting if you think about how to get to a couple 100,000. That's achievable. So that's how we break it down for ourselves. It's just, how do we get to the next stage? And also keep going. I mean, we've been fortunate enough to be in this ecosystem with other people who are working on the same problem, and everyone is really collaborative, because honestly, like, none of us are competing. There's just so much to do. So it is a nice community to be part of, to be honest.
Mm-hmm. Are there challenges with scale that are unique to kind of your material? I don't know, is the supply of the granules limited, for example, or something like that? Or is it just sort of the typical challenges with scaling to that level?
I would say it's the typical challenges because in part it's like a chicken and an egg situation, right? If there's the demand, the supply will be there. There's no like real shortage. It's just that how do we also make the cost and the demand and everything kind of work in symbiosis? But this has been done before. These kinds of challenges have been solved. So yeah, I think there'll always be hard problems, but I think it's something quite exciting because it feels like it's the right time in the world to be working on it. People want this solution. So we got lucky in that way. And the momentum is going to keep going and there are more and more people entering the market, which in a way just adds fire, right? Everyone's just trying to get there. So yeah, we're very optimistic.
Where do you see Shellworks in 10 years?
I mean, ideally, people are saying it's the cortex of materials for sustainable solutions.
I like it.
Yeah.
A few closing questions. How optimistic or pessimistic are you about the future of our planet and why?
I suppose I'm optimistic because I think optimism drives change. And it's why we don't like to talk about the problems. We only like to think about the opportunities because I think opportunities are exciting and within your grasp and you can get there.
I love it. I can hear that optimism in talking to you and it's contagious. I think it'd be a lot of fun to work with you. Who is one other person or company doing something to address climate change right now that's inspiring you?
I mean, I mentioned them once before, but I guess a shout out to Sway in California. They make seaweed-based packaging. Yeah, I think they also bring a lot of optimism. So on your down days, you go and check out what they're doing, and we're like, yeah. So yeah, I would say they're doing a phenomenal job, and it's always really inspiring to see how they're approaching it or the new ideas that they have. And yeah.
One thing I feel like I've learned talking to people in climate tech generally is the sort of competitive spirit you get in a lot of other industries isn't there as much. It's almost like we're all in this together. There's a big enough problem that we all need each other. And that community feel that you are referencing seems really strong. And just to say, I love that.
It's nice. I think it'd be daunting, to be honest. Like, it's nice to have competitors. It's like, okay, I can learn from someone else because I think it's quite a new space. And if you don't have that, it can be even more daunting, I think.
What advice do you have for someone not working in climate tech today who wants to do something to help?
I mean, one, it's an exciting space and there's so much opportunity and you don't have to be working on it to really be helping. Honestly, like anyone who is even like a shoulder for me to like talk to, like vent to, help, like they're all part of Shellworks journey. Like my roommates, my friends, everyone came and helped me scrub the floor when we first moved in. I mean, you don't have to, no role is like small enough. They're all really meaningful and like they help everyone get to the goals they're achieving. So maybe just try and find one or two friends and that's enough.
I love it. Insiya, it's been really fun talking to you. I have learned a lot and I love your approach and your optimism and what you're doing. I think it's a beautiful vision for the future without plastic waste. So thanks for taking the time.
Thank you. No, thank you for having me. It was a pleasure.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.